Okay, so in the last section we characterized our implicit knowledge of the phonology of our language, or grammatical knowledge, as being a kind of function, right, that can be applied to potentially any sequence of sounds. Right? So certainly we can apply our knowledge to words like pleek and find a way to pronounce them. Right? That's going to be more or less conforming to English grammar, but also we can apply that system of knowledge to words like koop or pnak. So we're going to need to be able to apply this function that is our phonology to a really, really wide variety of potential inputs. Right? And so those inputs in the sort of normal classical case would just be an existing lexical entry in your language. But what we've just seen is that your knowledge has to go beyond just being able to pronounce the words of your language, and it has to be able to be applied to a variety of other possible inputs that aren't possible words in your language. So here's the beginnings of a formal model of what that might look like. And there's going to be a fair bit of technical detail in here. It's basically an algorithm for characterizing what our grammatical system needs to be able to deal with. And if you don't understand every single computational level detail of what I'm describing here, it's not the end of the world, but the overarching idea here is that we're just trying to find a way to characterize what your phonological knowledge can be applied to, right? And the answer is going to be pretty much anything, right? So here's a characterization of what pretty much anything means. This is a procedure for the generative base. That's going to be the input to our grammatical function. Here's a way of specifying this. Start with a segment, which is really a feature matrix in our theory, and then specify it for, what do I have here? Consonantal, and sonorant, and continuant, and all of the other features that we're using to characterize sounds. So these are just different features, and I picked 3 at random here. It doesn't really matter which ones. The point is you're going to go through each one of these features and either make it plus or make it minus for every single feature. And then you're going to move on to the next segment and do the exact same thing until every single feature has been filled for every segment. Where there's really like whatever 20 or 30 features down here, I'm only showing you a few. Keep doing this till every feature is specified, then move on to the next segment, and do this as many times as you want, and then decide that we're done. So that's going to be a word ending. So terminate whenever you feel like it. So this is going to be the procedure for generating all the things to which our grammar might apply. What is this procedure going to generate? That is, what's the output of this initial step? Well, it's basically going to be any sequence of segments, of possible segments, with any combinations of possible feature values. So it's going to give you, things like pleek, but it's also going to give you lots of things like koop, or pnak, or even crazier things, right? Right? That's a possible output of this algorithm. And you might look at that and think, this is a crazy theory, why do we need to deal with that? But actually we saw some words in Tashlit Berber earlier this semester that don't look that different from these. And presumably, right, if an English speaker comes in contact with a lot of Tashlit Berber words, they find a way to pronounce them. So we really need to be able to apply our grammatical function to just about anything. This generative algorithm I just gave you for generating a base is basically just a characterization of what does anything mean, right? If we have to be able to apply our grammar to anything, here's the anything that we're talking about. It's basically any conceivable sequence of sounds that are any conceivable combination of features. So this is the base, and then what is our grammar? Well, in this theory, our grammar is going to describe how this hypothetical set of lexical forms, or base forms, is filtered down to the forms that are actually possible in a language. Right? So our grammar in this conception is basically going to consist of a description of how we take anything generated by this algorithm, including things like this, and turn them into English words, into sound sequences that obey the constraints we actually see in English. So some of these possible base forms that come out of this algorithm are going to be possible words in English that happen not to exist, like pleek. That's certainly a possible output of this base generation. But those are going to be treated inherently differently from non-occurring impossible words, like English coop. The base is going to generate either one of those forms, but our grammar is going to need to treat them differently. And that's going to encode this observation that accidental gaps in the lexicon are accidental, while systematic gaps in the lexicon are due to grammar. This is the conception of grammar that's going to help us get at that. Our job as phonologists, under this framing of what phonology is, our job is simply to discover what kinds of constraints, rules, or other generalizations are involved in filtering this infinite base down to the actually observed sound patterns of English, or the set of possible words in English. Right? So that's a big job. It's a big function. There's lots and lots and lots of details that go into that. But this is just a computational level attempt to define what we're actually doing in here. Now, in the semester, we're going to get lost in specific sound patterns and analyzing particular data sets, and we're not going to need to be keeping this grand vision of how grammar works in our mind at all times. But I think it is important to go over this, right, because it's really going to be governing everything that we do for the rest of this semester. Right? Our job as phonologists is to come up with what kinds of generalizations English speakers know about their language that allows them to deal with a potentially infinite number of inputs and convert them all to possible English words. That's basically what phonology is about. Here's an example not from English, but from Cyrenaican, which we looked at last time. And in Cyrenaican, we found that low front vowels are not allowed following emphatic consonants. So this was one of the little mini data sets that we looked at in one of the videos last week. And yeah, so following an emphatic consonant, you can't have a low front vowel. And we'll call those emphatic consonants the feature just plus or minus emph for now. And so here in the handout is a filter for Cyrenaican grammar in the form of a constraint. Right? So this is going to be the most basic form of grammatical knowledge that we'll posit this semester. It's going to be a constraint. It's a negative statement. It says, hey, my language doesn't allow sound sequences like this. And here's that Cyrenaican constraint in constraint form. Star means no, ungrammatical. We don't accept this as part of our language. Emphatic consonant plus emph followed by a vowel that is low and not back. So here is the Cyrenaican constraint. In the handout, I left out the plus syllabic part because presumably only vowels can be low and non-back, but you can also put in the plus syllabic just to make it clear that we are talking about vowels. And this constraint just says, don't have something with this feature and have it followed by something with this feature. It says, no, if you do this, you are not a Cyrenaican word, right? It doesn't specify what would happen if a lexical entry or a foreign form or some other kind of input to the grammar did have such a sequence, right? It doesn't say what a Cyrenaican speaker would do if they were confronted with a word like this or with a form like this. And this is an important property of constraints. This is why I'm saying they're the most basic form of phonological knowledge that we're going to deal with, because all they say is what is and isn't allowed in a language. They don't say what you ought to do if you find one of these things in your base or in your input, right? Or in your lexicon even. It doesn't tell you what you should do when you're confronted with a sound sequence like this, it just says, it ain't Cyrenaican. Now there is a different way of writing filters that does say what would happen to the offending sequence, and this is a older, more classical, and maybe better known kind of phonological device that's referred to as a rewrite rule or a phonological rule. And it's going to be important to understand both formats, although we're mainly going to be pursuing constraints in this class for reasons that will hopefully become clear later. But it is worth understanding what phonological rules look like. And so here's one possible rule for Cyrenaican. There's several that you could write. And the way it's written here is in this phonological rule notation. Sorry, that's an arrow. You can see this in the handout in any case. Okay, well, what does this one say? It says plus low becomes plus back in the context of a preceding emphatic consonant. A little bit more technically, we could say, hey, scan every input form, every potential word, everything in your generative base, anything that comes up, scan it for an instance of plus low. And if that feature is inside a feature matrix that occurs after this emphatic feature, or sorry, after another matrix that has plus emphatic inside it, this little underscore stands for where we're looking. So we're looking over here for this feature. And if you find it, then take this feature and take the feature matrix and change the value of the feature back to plus. Now, maybe back was already plus, in which case the rule won't do anything. But maybe this sound used to be minus back, as in this constraint. Now it's going to become plus. So this is the phonological rule formalism. And this is sort of a specific example for Cyrenaican. But more generally, we can state the form of a phonological rule using variables over features or sets of features. And the idea here is that a phonological rule consists of some structural description. This is the thing that you're going to need to use to identify the natural class of segments that are subject to the rule. It's going to involve some change. In this case, we're changing a different feature. And then that change is going to happen in some context. And so we separate the context using the slash notation. And then we show the target segment, like where we're trying to look for the structural description, using an underscore. And you can have a preceding context or a following context. This is sometimes also called the environment of the rule. So if you think about this as A becomes B in the context of preceding C and following D, this happens to be nothing in this rule, but there could have been another feature there. What we can say is that items of type A are predictably B when they're in between C's and D's. So in this particular case, low vowels are predictably back when they're in the context of a preceding emphatic consonant and anything following them. Or, it doesn't matter what follows them. So this is slightly more complicated, obviously, than the constraint. And the reason why is because this is really combining two different aspects of our function, our generative function, that's our phonological grammatical knowledge. It's combining an observable fact about possible surface forms, that is, possible outputs of our grammar in Cyrenaican. So in Cyrenaican, low vowels are always back when they're following emphatic consonants. This is an observable fact about the language. Although in theory, words could have low front vowels in this position, that just seems not to be allowed after emphatic consonants. Right? This is something you can see just by looking at the language. But it also presents a description of how sounds might change in different contexts. So here we declared that low front vowels are going to become back if they find themselves in this unfortunate position. We don't actually have any firm evidence for that. All we saw in the language is expressed by this constraint. All we saw is that you don't get emphatic consonants followed by low front vowels. We didn't see what would happen if you got a sequence like this. But to write the rule, you have to make a guess about that. Or, hopefully it's an educated guess. Maybe it's even based on observed facts. But it's important to note that one of the reasons we're going to mainly focus on constraints in here and not quite as much on these rules is because you can't write a rule without making some kind of a statement about what would happen to conceivable but impossible sequences of sounds. Now, in the data we saw from Cyrenaican, all we saw was a bunch of emphatic consonants that were followed by low back vowels and not by low front vowels. We didn't see what would happen if you did have an emphatic consonant followed by a low front vowel. The rule says that vowel will become back. But that's only one possibility based on the data we saw. Maybe the emphatic consonant becomes unemphatic instead. That would be a different rule. Maybe the vowel deletes. That would be a different rule. Maybe the consonant deletes. There's some method in Cyrenaican grammar, some filter for resisting sequences like this, but we don't necessarily know what would happen to these sequences. In a rule, we have to make a guess about that. In a constraint, we don't need any such guess. How would we get evidence about this? This is going to be something that comes up a lot in the last part of this semester. We're not going to fully go into it yet, but it's worth thinking about. If you wanted to find out what happened in sequences like this, how could you go about doing that? I'll give you a minute to think about that, and I'll give you a couple quick possible answers. Well, here's one way. You could look at words from other languages that might allow sequences like this and see if Cyrenaican has ever borrowed words from a language that allows words like this. Because linguistic borrowing across languages happens all the time. In fact, it's a whole subfield of phonology. We call it loanword phonology. You could see what Cyrenaican does with sequences like this from other languages. That would be a way to do it. In fact, we'll be looking at loanword phonology in a week or two. You could go into a laboratory and either write down or in some other way tell Cyrenaican speakers to pronounce sequences like this and see what comes out. That might not be a great methodology. I mean, if you give it to them in spoken sounds, they're probably just going to imitate the spoken sounds, whether it's a well-formed word of Cyrenaican or not. If you give it to them in spelling, well, first of all, there might not be any way to spell this. I don't actually know. But even if you could, people's knowledge of their spelling systems might be have all sorts of other things going on in it besides their phonological knowledge. So it's a little bit dangerous to sort of use those laboratory experiments. Here's another idea, and this one is going to correspond to something we'll look at later this semester that's also super important. What if you could find one morpheme that ended in an emphatic consonant and a second morpheme that begins with a low front vowel? Assuming both of those morpheme shapes are possible in Cyrenaican, you might then be able to put the two morphemes together. And that could be two words, it could be a prefix and a root, it could be a root and a suffix. Any way you can get these two features next to each other through morphological concatenation, well, then you'd be able to directly observe what happens with sequences like this in Cyrenaican. And that kind of a examination where you get the features of interest next to each other by putting morphemes together or words together, that's going to result in what we call alternations, right? Where the same underlying segment in the same morpheme takes on different values when it's next to different kinds of sounds, right? And this is going to be a really important part of phonology but it's super complicated and we're not going to get there for at least a month. But those are some answers about how you might get evidence about this. For now, we're not going to go to alternations right away, just because they tend to be conceptually very tricky. We're going to mostly stick with constraints in this first part of the class, and we're going to be keeping in mind that, you know, all this says is that we don't have things like this, but we don't have a good description of what would happen if we did have things like this. And we're going to keep in mind as well that there's this rule formalism. We need to be able to know how to read these rules and how to write them. And this rule formalism is different in that it not only encodes the lack of certain sequences in a language, but also says what would happen if those sequences arose. Right? So we're going to use both kinds of formalism. This one's going to be primary for now, but it's worth keeping the rule formalism in mind as well.